What's up, YouTube?
And welcome to our YouTube channel.
And today we're going to be talking about our fish kill project. Alright, so here's the background. Our project focuses on the River of Fishkill, a sudden event that shocked the local community. The Snake River is the main source of water for Riverwood. People rely on it for drinking, farming, and recreation. But in early September, residents found hundreds of dead fish along a 1 mile stretch of river. The strange part was that the water looked totally normal, clear, colorless, and without any bad smell. The town immediately stopped using the water and called scientists in the EPA to investigate. What made the event a mystery was that there was no visible signs of pollution, so our group wanted to find out what invisible factors could have caused it.
But how can we solve this issue? Let's ask locals in the area how they feel about the water. Follow me. Sir, how did you feel about the water you just drank?
It was really nasty.
Oh, how can we prevent that? We believe the fish kill was caused by chemical pollution from an upstream industrial source near the Snake River Dam. If harmful chemicals like nitrates or heavy metals enter the water, they could have reduced oxygen levels or directly poison fish. The fact that the deaths happened to downstream of the dam supports this idea, because water from that area would carry pollutants right into Riverwood. We also ruled out diseases or temperature changes. Since the fish looked healthy and the water temperature stayed normal, our hypothesis focuses on invisible chemical contaminations as the main cause. Let's ask scientists how we could fix this. Hey look, here's one of our scientists. Let's see what she has to say.
Oh hi, here are some of the methods that we use for our hypothesis. To testify our hypothesis, we used 3 main methods. First, we collected water samples 3 times a day for 1 week from 5 different locations, starting upstream of the dam and ending downstream near Riverwood. We tested each sample for pH, dissolved oxygen, nitrate, and heavy metals. Second, we collected both dead and living fishes to check for tissue damage and toxins in the lab. Finally, we interviewed residents, factory managers, and farmers to learn about any recent spills, dam maintenance, or unusual weather. Together, these steps helped us connect chemical data with what actually happened in the community.
That's really cool to hear.
Thank you. Here's what my partner has to say about it.
Hey there, I'll be talking about the data that supports our methods and hypothesis. Our study reveals some clear facts. Over the past 2 years, nitrogen levels in Snake River slowly increased, while dissolved oxygen levels dropped close to the danger zone for fish, around 4 milligrams per liter. Then, during the week of September 1st to 7th, we saw a sharp spike in nitrates and a sudden crash in oxygen levels below the 3 milligrams per liter. The temperature stayed stable, which ruled out heat as the cause. These trends line up perfectly with the timing of the fish deaths, showing that pollution most likely builds up over time and finally reached the toxic levels right before the fish kill. As you see here are the graphs. Right here is the 2-year trend, and right here is September 1st to 7th with the natural levels.
Hey, I'm Dylan, and this is what I gotta say to conclude our presentation. Based on all of our evidence, our hypothesis was supported. The water test, fish samples, and interview results of all point industrial pollution. As the cause of the Riverwood fish kill, the sudden oxygen crash matches what happens when chemicals enter a river and disrupt its balance. To prevent this from happening again, Riverwood should enforce stricter waste controls for factories, build vegetation buffers along the river to filter runoff, and schedule runoff EPA testing. This mystery taught us that protecting the Snake River is critical because clean water supports both the environment and the people who depend on it.
I'm Zach.
I'm Jaden.
And I'm Ivy.
I'm Dylan.
And thank you.
For listening to our presentation.
See ya, YouTube!